do some of these calculations in Excel to help you with your test this upcoming week. So what I've done is I have an Excel spreadsheet in one screen and then your test review in the other. And then we can work through this I can work through this as long as I can. But a lot of the problems on this test review actually repeat. So I might skip some of those, but I really just want to make sure that you guys are comfortable with the majority of these problems and the majority of the different types of content questions that you'll see. So we can just go through the list down the review. So the first question on number 1, the following frequency distribution represents student scores on a quiz. Draw a histogram for the above frequency distribution. Well, what's fairly easy about these types of questions is that you're letting each bar represent one of the student scores. So we should have a bar for 0, 1, 2, 3, 4, and 5. And then the frequency is just going to be your y-axis value. So you're looking for totals of 427,894. So this looks like 426. That's not going to be that one. 427,894. And you can just see the numbers right around. I might be able to annotate these screens. Yeah, you're looking for these numbers right there. Those tell you your frequency. So that's what we're going to check. We're going to check this one. 427,894. Check answer. And it should tell us that we're right. We're correct. All right, moving down. So the following questions pertain to the shapes of the distributions that you'll see throughout the semester in 1070. If the shape looks approximately rectangular, that is by definition what a uniform distribution is. You can notice that the y values or the frequencies are roughly the same around 5, so we say they're uniform. Check answer. And most students can get the uniform and the normal. Normal just means that it's bell-shaped. Most of your data is centered at the center, and then as you go away from the middle, so to the left of 14.75 and the right of 14.75, the frequencies decrease. What tends to happen on tests is that students get left and right skewed mixed up. And for these types of questions, you're just looking at where does the tail of a distribution get pulled to. So if I were to just draw, a distribution around the histogram, you'll see that a lot of your data is clustered to the left of the data set, and then the frequencies go down as I move to the right. So if the tail of the distribution, or the tail right over here, gets pulled to the right, then we say that the distribution is right skewed. And similarly, if the distribution gets pulled to the left, we say that it is left skewed. So here, a bulk of your distribution's values are right around 20, but then you'll see that as you go to the left, your frequencies decrease. It's pulled to the left. So we can check our answer, and the distribution is left skewed. And as I said, that's where most of the problems occur on this first test, where you get left and right skewed. Same idea. It's not uniform, and you can just do process of elimination with these questions. If your y values are roughly the same as you go from left to right, it's uniform. If it's bell-shaped, most of your data is clustered at the center, and then your frequencies decrease on both sides. We would say it's approximately normal. But it's neither the case here. Most of your data is around this value of 7, and then as you go to the right, your frequencies decrease. You're getting pulled to the right. So we're right skewed. Here, the bar graph below displays 2015-2016 data collected by the Centers for Disease Control and Prevention on cases of the Zika virus found in the U.S. Although for all cases, the virus was contracted internationally. Not all 50 states are represented. So, here, the first question just says, how many states are represented in the histogram? Well, to figure that out, all we have to do is just add up the total number or the frequency of each bar. So, in Excel, this can be easily done. Now, in Excel, to do any calculation, as I'm sure you guys are aware of now, you need to start with the equal sign. Excel won't register that you're about to do some math unless there's an equal sign. So the first bar, if you can look, has a frequency of 34. The second bar has a frequency of 4. Then we get a 0. Then we get an 8. And then we get a 3. Which we get 49. And if you'll notice that there's not all 50 states are represented. So we should get something less than 50. In this case, 49. What percentage of the states in the histogram recorded 40 or less? Well, we have a total of 49 states represented in the histogram, and we're looking to see how many are 40 or less. Well, 40 or less would just be our x-axis scale. You know, this first bar represents 0 through 10 cases, the second bar 10 through 20, third bar 20 through 30, and then the fourth bar is 30 through 40. So in that case, we're just going to count the frequencies for these first 4 bars, not including the last one, because the last bar represents greater than 40. So we can just do 34 plus 4 plus 0 plus 8. Now to save some time in Excel, put these values in a parentheses so that order of operations is good. It adds the numerator, and then we're going to divide by the total. And that'll give us the percentage 40 or less. Now, be careful here. Excel gives you a decimal. It wants the nearest whole percent. Well, if you want to, just in Excel, if you can't see the percentage, just multiply this value by 100. And we get 93.87755%. And then we can also use our rounding tools up here to increase and decrease the decimal. So if you're looking for the nearest whole percent, right here is 94. Yay. Alright, here we go. Find the mean of the frequency distribution. This tends to be a little bit tricky for students because it's representing your data set in a way that you're probably not used to. So I'm going to go ahead and put these into Excel. So 0, 1, 2, 3, 4, 5 are our x values, and the frequency with which they occur are the right columns. So 0 occurs once, 1 occurs 4 times, 2 occurs 8, 3 occurs 6, 4 occurs 7 times, and then 5 occurs 4 times. So there are really 2 ways to do this. One way is significantly easier than the other. And this is why frequency distributions and representing your data set as a frequency distribution can make things a little bit easier for you. Another way of writing this data set is saying that 0 occurs once, then we have 1 4 times, 1, 2, 3, 4. 2 occurs 8, 1, 2, 3, 4, 5, 6, 7, 8. You know, 3 occurs 6 times. And we can go on with that. And it tends to take a long time, especially as the frequency increases. So this is not the way that we want to do that. If you want to, if that's better for you, you can represent your data set that way, but that's not how I'm going to do it. What we want to do first is to see what is the total number of values in this data set. So I'm going to use the Excel sum function to add up all of my frequencies. And what this does is it's going to add all the frequencies and put it in this cell right here. So the total number of values in this distribution is 30. And so what we want to do now is find the mean. Well, what's really nice is that, so we know 0 occurs once, 1 occurs 4 times, 2 occurs 8 times, 3 occurs 6, 4 occurs 7, and 5 occurs 4. So to find the mean, really we just add up all of our data values and divide by the total number that there are. So if we were going to do this the long way, we would do, 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2, and so forth. But it's really long. Well, if you remember from maybe elementary school, maybe middle school, repeated addition is just multiplication. So what we can do is make this a little bit easier on us and just say that to find the mean, we can do, 0 times 1 plus 1 times 4 plus 2 times 8 plus 3 times 6 plus 4 times 7 plus 5 times 4. Well, Excel has this really cool function called sum product. Where it's going to do that, it's going to add up a bunch of products, product being multiplication. So in Excel, we can highlight our x values, make sure you pay attention to the syntax of the function. So an array is just a list of numbers. So array 1, I'm going to highlight my x values. And then Excel tells us to do a comma. So once we do a comma, it's now going to switch to an array 2. I'm going to highlight my frequencies. So what this function is going to do is it's going to take all of our x values, multiply it by its frequency for all of the x's, and then add it up. So this value is 86. Now this isn't quite the mean yet, so let's keep the mean down. So to find the mean, though, in a data set, we take all the values, add them up, and we divide by the total number. So we divided by 30. So we took our value of the sum product in B12, divided it by our total in B11. And I just click these values in Excel. That way you don't have to worry about rounding anything, and your answer is as exact as possible. And so you'll notice the mean of 2.8667, which is right there. Answer is correct. All right. Next one, find the median. Well, it would be really nice if Excel had a median function when its data is represented as a frequency distribution. 1, 2, 3, 4, 5, 6. The frequency is 3, 2, 6, 7, 9, 3. Well, so the median is just your middle number in the data set. If you were to order your number, if you were to write your numbers as a list and start from the smallest and go to the highest, and find the exact middle, that is your median. And you've probably done that type of median calculation before in elementary school, middle school. But just like with the mean, when you represent your data values as a frequency distribution, things get a little bit tricky. So what you want to do here, though, is we want to know how many values are in our data set. So we're going to do the sum function one more time, and then just highlight our frequencies. So what this tells us is that there are 30 values in the data set. Well, if you remember from your Lagranita readings, the median is harder to find, or the median of the distribution is calculated as the exact middle if the data set has an odd number of values. But with an even number of values, you have to kind of think about it a little bit more. So with 30 values in your data set, what you want to is see where the middle is. So the middle value is going to be between the 15th and the 16th value in your distribution. And all I did with that was just taking half of 30. So our median is going to be between the 15th and the 16th value. Well, what we want to do then is just use our frequencies to kind of say where is the 15th and 16th value. Well, up until this point, the 1 occurs 3 times. So here's the first 3 values. Now we have 2, 2. So now we're at the 5th value, the 11th value, and then 4 goes all the way up to the 16th value. 11 plus 7, or 18, sorry. So that means that our 15th and 16th value in our distribution is 4. So if you remember, what you do with that is the median is the value between your 15th and 16th. So we just take our 15th value, add it to our 16th value, and then we divide by 2, which is just 4. A little bit tricky, and if you wanted to, I mean, honestly, you're the one taking the test. You could do list 1 3 times, 2 2 times, 3 6 times, 4 7 times, 5 9 times, 6 3 times. And then in Excel, if you have a data set represented like this, now this isn't the way that I recommend because it's going to take longer listing it all out, then use the median function. So =MED, it tells you median. So we double click, and then we can just highlight the data. Right there. Close parentheses, enter. We get the same thing. This second way takes a little bit longer. The first way kind of relies on the fact that knowing you have 30 values in your distribution, your median is going to be between the 15th and 16th values. All right, moving on. Mode. Given the following data set, find the mode. Well, Excel is really helpful with all of these things. 38, 66, 84, 82, 91, 84, 84 again, 69, 82. Now, if you remember, the mode is the value in your data set that occurs the most. And as I typed it, you might have seen that what it looks to be is 84. 84 occurs 3 times. So if you just want to look at your data set and you're just looking which data value appears the most, in this case, 84. But Excel, if you don't want to do it that way, if you want to rely completely on your computer, equal sign is the first thing to do, M-O-D-E, mode. So mode multi is a function that returns multiple modes if you have values that occur the same number of times. Mode singular, let's go ahead and do that. Highlight the data, enter, and it outputs 84. 84 occurs the most. Alright. Use the cover issue to find the mode. Alright, so here, use the probability to find the mode. Well, like we just talked about, the mode is the value that occurs the most. So, your 1 occurs 3 times, 2 occurs 2 times, 3 occurs 6, 4 occurs 7, 5 occurs 9, and 6 occurs 3 times. Well, the mode is going to be the one with the highest frequency. The highest frequency is 9, and that corresponds to a value of 5. The following are the annual sales for the employees of a small business. Number 12. Well, first thing you want to do is just put this into Excel. There are only 6 data values. You can just type those in. 46,000, 49,000, 31,000, 38,000, and then 124,000. Wow. And then find the median. Well, in Excel, once the data is in there, just do equal sign MED, median will pop up, double click it, and then highlight your numbers. So, your median is 47,000. Check answer. Which value, mean or median, better represents the typical salary for an employee of this company? So, what you want to do is look back at your data set and notice that up to 6 values, the first 5, they're not the same, but they're roughly the same, between 30 and 50,000 that they're making. But we have this value over here, 124,000, which is definitely an outlier in this distribution. So, because you have this outlier here, the mean is not going to be the best representation of the average or typical salary. The mean is not resistant to outliers, meaning it is affected by outliers. Think back to the first couple problems with your shapes of your distribution. When you have a skewed distribution, the mean of the distribution actually gets pulled towards that tail. It makes it not as accurate. So what we want to then say is, because the mean wouldn't be accurate, the median would be more accurate. The median is said to be resistant to outliers. So in a distribution with outliers, the median is a better representation for the typical or the average value. Number 13. Following houses are for sale in that neighborhood. If he's considering putting his house up for sale, find the median and determine which would be a more accurate value. So same idea. So we want to find the mean and the median. So we're going to put these into Excel. 40,000, 89,000, too much. 91,000, 95,000, 97,000. So we want to find the mean and the median. So most of the functions in Excel correspond to what you're trying to find. Meaning, if I want to find the median, I just type in MED. Median will pop up and I highlight the data. 91,000. So, did I miss a value? 2, 3, 4. I did miss a value. We have 40, 89, 91, 93. Oops. So in Excel, we can just keep this down. So, our median is then 92,000. Well, we're also finding the mean. Well, the median of 92,000 eliminates answer choices A and B. Well, if you're going to use the functions based on their names, if you start typing in MEAN, for mean, you get these things, a geometric mean, a harmonic mean, and a trimmed mean, which that's not what we're looking for. So the mean is a little different, but the mean is just a fancy way of saying average, and that function is in Excel. So average, highlight these values, hit enter. And so then we see that the mean of 84,166 and the median of 92, so those are the same. Now we want to say the mean describes accurately average values of his neighborhood better, or the median. Well, what do you think? So let's look at our data values. Once again, we have most of our data values are around 90,000. You know, we have 89, 91, 93, 95, and 97. But we have this one value here that is an outlier. It's pulling our tail to the left. And actually that makes sense if you look at our mean and median. Our mean is pulled towards the outlier. That's why it's less than the median. So in my opinion, the median is better because of the outlier, which that's what happens. All right. Jay Selly has the following coins in a bank. If one coin is withdrawn, find the most. Well, we're just looking to see what has the highest frequency. So once again, our highest frequency is 40, and that corresponds to a penny. 0.01 cents, or 0.01. The following frequency distribution represents student scores on a quiz. Find the median value of the quiz scores. So this kind of goes back to that question that we did a little bit ago. Well, what we want to do, because we want to do the easier way, 0, 1, 2, 3, 4, 5. That's our x value. Our frequencies are 3, 2, 6, 7, 9, 3. So let's first see how many values in our distribution we have by adding up the frequencies. That's 30 once again. So that tells us that our median is between the 15th and the 16th value of the distribution. So going down the frequency list again, we see 0 corresponds to our first 3, 1 first 2, so we're at our 5th value, we're at the 11th value, up until 3 to get to the 18th value. So the 15th and the 16th value are 3. So the average of those, 3 plus 3 divided by 3, or divided by 2, is 3. And there's your median. Use the probability distribution to find the mean. All right, we'll do this again. So our frequencies, we're just going to go down 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then 5, 3, 6, 7, 7, 2. And you'll notice, while I like to click on values in Excel, our value of the median, you might have seen, or the sum, changed as I change the values. And that's why it's helpful to just click on values when you do formulas in Excel, because it'll immediately change it. So we want the mean. Actually, I shouldn't have deleted that. We need first the total number of values in our distribution by adding up the frequency, so 30. And the last thing we want to do is find the sum of all the x values. Well, because our data is represented as a frequency distribution, to find the sum, we use sum product, which is, if you just start typing in sum, it's down there. And so we're going to multiply our x values by our frequencies. So the sum of all the x values is 104. The mean would then be the sum of the x values divided by the total number, 3.46667. There you go. I don't think we need to do 17. Based on the fact that it's basically the same thing. So we'll skip that one. Number 18. The following frequency distribution represents student scores on a quiz. Find the mode. Well, the mode is the value that occurs the most. And so you're looking for the highest frequency. Well, with this data set, however, notice that a frequency of 9 occurs twice. It occurs at the x value of 0, and it occurs at the x value of 4. That can happen. That's not a mistake. And all we then need to do is just list them both as modes. This distribution is 2 modes, 0 and 4. Usually has the following coins in a bank. If one coin is withdrawn, find the mean. Well, I'm going to show you why it's good, like I said, to click on the values in Excel. So I'm going to change these. 0.01, 0.05, 0.1, 0.25, 0.5, and then $1. And then the frequencies are different. 6, 38, 25, 21, 6, and 4. So by clicking on the values in Excel, I made my sum formula, my sum product, and the mean. It automatically changed the values themselves. So on the test, if one question occurs more than once, if you do it this way, you've done most of the work for the first question, and you don't have to do any work except change the values for the second. So this value is 0.1671. There's the mean. And you'll notice it's just the sum product, the sum of us multiplying each x value by its frequency, dividing by the total. Find the median. We've already done one like that. Given the following data set, find the mode. We've already done one like that. You can kind of see that the value 74 occurs the most, or you could use or we could use the mode function in Excel. There you go. Alright, given two data sets, A and B, calculate the mean and median of each. We can do that. So we'll do, in Excel, data set A, data set B, and then we'll do 1, 3, 4, 5, 27. That's a big jump. And then B is 1.2, 2.5, 9.6, and then 20.5. So we'll do mean A, mean B, median A, median B. It will help too on your test if you kind of list everything out in an organized way, so that if you have to go back and look and you're checking your answers, you know exactly where each thing is. You know, I wasn't really doing that for the first couple problems. I was just kind of throwing everything in Excel. But it might be best for you just to do that so you know exactly where each question is located. So the mean, we do equal sign. Remember, we don't type in mean, we type in average. And we're going to highlight the values. And we can highlight horizontally. We don't have to do it vertically. There you go. I'm just going to go ahead and do it for everyone. Average of data set B. We can go ahead and do the median, equal sign median, data set A, and then equal sign median for data set B. And there they all are. So what is the mean of data set A rounded to the nearest tenth? Well, it looks to be, you can check just to see if it is the nearest tenth. It's exactly 8. Check answer. There you go. Find the mean of data set B, rounded to the nearest tenth. Well, Excel output our answer here as the nearest hundredth. You will get counted wrong on the test if you don't round to the appropriate values. And that's why we had that Chapter 1 homework assignment, using Excel to round. So because we have 2 decimal places, we want 1. We're going to decrease the decimal by 1. So the mean is approximately 8.5. The median of data set A, rounded to the nearest tenth. Well, the median of A we see is just 4. Exactly 4. And then the median of B, rounded to the nearest tenth. Well, we need 1 decimal place. Excel output 2. You need to do 1 less. So go to the number, right there, so 6.1. Easy. Alright, the table below lists the national average hourly wages for some occupations. What is the mode? Alright, well the mode is basically pretty self-explanatory. Just find the data value that occurs the most. Alright, the bar graph below displays the number of people in the U.S. in different career fields. Calculate the mean and median of the data set. So the number of people in millions. Alright, so we can put this into Excel. Let's see, we have 12 million, 5 million, that looks like 33, 3, 17, 26, and 19. Well, equal sign mean, or equal sign average, I'm sorry. To find the mean, highlight and drag. So it looks like down to the nearest tenth, so this output 5 decimals, we want 1. So we decrease So it's 16.4. And then the median, I'm just going to go in and change the word average to median just to save some time. So you see, what a lot of students do on these tests is they will actually try and do this all by hand, because you don't get a calculator, you only get Excel. So when they do the mean and the median, if it's a small enough data set, they might try and do it by hand, but that's a waste of time. That might waste 5 minutes on a problem, and your test is definitely going to contain more than that. So you want to make sure that you're using your time effectively by using Excel as much as possible. So here we have a question that has a data set that's already in Excel. So if you get to a question like this, just click the link here, and it will automatically give you this particular data set represented in Excel. So you don't have to type anything in because that would take the whole test time. Enable editing. Let's just scoot that to the right. So if you want to make it so that it's split 50-50, eMath and Excel, just take your cursor, put it on top in the green area, click, and you can drag it, and keep going to the right, and eventually it'll automatically go to half of the screen. So we want, what does it mean of the top 50 companies and chains with respect to the 2014 U.S. system-wide sales? So what we're looking for is, I'll make this full screen, system-wide sales. So that's the first column, and I'll just put it over here. So equal sign, average, and then just click and drag. It's a big data set, so you might not see the output anymore, but once you highlight it, just hit enter, and then it's there for you. 3,415 and 3 cents. 341503. Nearest hundred. So 3415.03. Check the answer. There you go. So this is a new one. So this question says, what is the variance of the top 50 companies and chains? So variance is just a measure of spread in your distribution. It's a way of summarizing how spread out your values are. In Excel, though, there are functions to do this. I know that you have complicated formulas in your Logitech, but trust me when I say that you do not have to do it by hand. We're looking for the variance, so we can do VAR. And here are all the variance functions in Excel. Now, this might sound confusing. The first one that pops up, var.p, is not the one that we want to use. We want to use var.s. So the difference between the two of these is that last letter, P or S. P stands for population, and S stands for sample. Rarely, if ever, do we know the actual population of data set, or of the population values. So we want to always stick to S because we're always going to assume that the data values that we're working with represent a sample of some population. So var.s is what we're going to use. And just like with mean, just like with median, all we have to do now is highlight the actual values. And then hit enter. And there we go. And so what does it want with this? What is the variance of, enter your answer in the box below, do not use commas, 2 decimal places. So we'll go here, and we'll get 2 decimal places. There we go. Come on. So, our variance is a very big number, 30331,757.59. And this is an important thing to pay attention to. Excel outputs a whole number. And it's always a good thing to check to see if Excel is not displaying any of the decimals. Because if you had typed, that into Excel without the decimals, it would have counted it as wrong. And on your test, you just lost a few points. So the next thing is the standard deviation. The standard deviation, like the variance, is a measure of spread. You see standard deviation much more than variance. And to find standard deviation, just start doing ST for standard, and then you'll notice all these things pop up. Standardized, that calculates something called the z-score. We'll do that next. But just like with variance, you do not want .p or point .p. because that assumes that the data set that we're working with represents a population, and we are assuming in this class that it represents a sample. So we use stdev.s, and then we can highlight and click enter. And we see that we get 5,507 points. What does it want? 2 decimal places. If you've been paying attention to your reading, though, there is another way to find the standard deviation, because there is a relationship between the variance and the standard deviation. The standard deviation is just the square root of the variance. So while we use the standard deviation function in Excel to find it, which is fine, another way would have been able to just do equal sign, click your variance, and then let's just do it this way. Let's type in SQRT. SQRT, if you look at Excel, it tells you returns the square root of a number. So double click it, click the variance, hit enter. And what you'll notice is that it's the exact same value that we calculated using the Excel function for standard deviation. They're both 5,507.43. Either way is fine. Just know that if you found the variance, you can easily find the standard deviation by just taking the square root. No need for more functions. Alright, let's click out of that one. We're done with that set. Alright, so back to our original spreadsheet. Find the range of the following numbers. Well, if you want to do range, let me just type this data set in first. 2, 3, 27, 21, 26, 29, 20, and 14. So it would be really nice if you could just type in range into Excel and it had a function already in for you. If you type in range, you see that that's not what happens. So we have to be a little bit creative with how we find the range. Well, the range is just the difference between the maximum value and the minimum value. And Excel does have functions for those. So equal to max, double click it, and then just highlight your data set. Hit enter. So the maximum value is 29. And you can actually see and look that, the max is 29. You don't have to use a function to do it. It's just, if you're kind of strapped for time and you're kind of stressing out a little bit, just use Excel. Let it do all the thinking for you. So our max is 29, our minimum is 2. So our range is their difference, 27. Or just do equal sign, 29, click it, minus, click 2, 27. There you go. Now I'm not going to do the next one. It's basically the same thing. Alright. But if your data is represented as a frequency distribution, the range is pretty simple. You automatically see what your maximum x value is and what your minimum x value is. Because the frequency distribution just says that 0 occurs 4 times, 1 occurs 4 times, all the way up to 5 occurring 4 times. So your maximum x value is 5, your minimum x value is 0, so the range is 5 minus 0. What does it say? Find the range of the frequency. Oh, the frequencies. I'm sorry. I wasn't paying attention. So the range of the frequency would just be, maybe if we want to do that in Excel, 8864. Pay attention to what I just did because I wasn't paying attention. So we just want the max. Highlight. Minimum. Highlight, which will be 4. So your range is 8 minus 4, which is 4. There you go. Sorry, I wasn't paying attention. Alright, so the box plot below displays the distribution of SAT scores in 2 different schools. So we have 2 schools, Shoretown and Suburbia, and then their SAT score range. So which school had more students that took the SAT? Well, the first thing I'll just tell you is that box plots do nothing to convey the actual sample size. And this is a trick question. All a box plot tells you is what's called the 5-number summary. Your minimum, your first quartile, your median, your third quartile, and your max. Nothing about the actual samples. So here, the box plots do not provide enough data to tell. So make sure you pay attention to that. So what is the range of SAT scores between Q1 and Q3 in suburbia? So Q1 and Q3 are represented as the edges of the box. So for suburbia, Q1 is our first value. Q1 is the first quartile. It's this value here, which it tells us is 920. Q3 is just the upper limit for the box, which is this 1,180. And then their range, a fancy way of saying this is the IQR, the interquartile range, the range of your quartiles, is just Q3 minus Q1, so 260. And so you'll notice that it asks you for the range between Q1 and Q3, and then it asks you for the IQR for the SAT scores in Shoretown. They both mean the exact same thing, but they're just asking you for the different distributions. So the first one was the IQR for the suburbia. Now we're going to do Shoretown. Well, we've already have this set up in Excel, so let's just see. What's Q1 of Shoretown? Q1 is 805. Q3 of Shoretown is 1,125. Therefore, Excel automatically output the IQR as 320. Check it. And we're done. Alright, a study was conducted on the overall fuel economy for the top 10 compact mid-size, okay, blah, blah, blah. The purpose of the study was to examine how the overall fuel economy is affected by the type of car. So that first sentence, the second sentence actually answers our first question. What is the explanatory variable? Well, we're trying to see, does the type of car determine the fuel economy? So our explanatory variable would be type of car. And what we're trying to do is explain the fuel economy, which is our response variable. We're letting type of car indicate if there's any influence of the fuel economy. And there we go. So here's a 5-number summary for the compact car. So let me highlight this and put it into Excel. I wonder if I can just do compact. Whatever. Highlight it all. Control C. You could also just hit copy. We're going to put it in Excel for us. So the 5-number summary is the minimum of the data set, the first quartile, the median of the data set, the third quartile, and the max. Now, what's really nice, though, is that Excel also has more functions in it to determine all of these things. And if they're doing the 5-number summary, we could just do minimum and, highlight. We're doing this for what? Compact cars. So that's the second column. So the minimum is 27. Q1, we're looking for the first quartile. Well, there is a quartile function in Excel. I just clicked the third one that just says quartile. And we always want to highlight our data. That's what an array is. So there it is. And then comma. So what Excel will do now is indicate some numbers, 0, 1, 2, 3, or 4. So that's your job. You're going to type in 0, 1, 2, 3, or 4 based on what value that you are trying to find. So you'll notice if you type a 0 after this comma, Excel will output the minimum. If you type a 1, it'll output the first quartile. If you do a comma 2, it'll be the median. So this quartile function can be thought of as a function that will output all 5 numbers of the 5-number summary. Well, we've already found the minimum. Well, if we did 0, notice that it does give you 27. So it will do the correct minimum. But we are looking for the first quartile. So I'm going to change that 0 to a 1. And then we can do the 5-number summary again. We're going to do quartile. Highlight the data set. And then we'll do a comma. Now, you'll see at 2 it says median. Well, we could have used the median function. No big deal. Q3 would be quartile. Highlight your data. Comma 3. And then our max. So we can do either the max function or the quartile function. Just to be consistent, I'll do quartile. Comma 4. And then it automatically gives us our 5-number summary. And it says rounded to the nearest tenth. So I'm going to highlight all these at once. I wonder if that'll work. And just decrease the decimal. There we go. It did. It changed them all to one decimal place. Please pay attention to this nearest tenth part, because the test, if it asks you something similar, you need to make sure you really do pay attention to the number of decimals, because it will count you incorrect if you do anything other than what it asks you. So 36.3, 36.5, 39.8, and then 43. There we go. I'm not going to do the 5-number summary for the mid-sized cars or the luxury. It's the same thing. And so then it asks us for a box plot. Well, assuming we've done the first two, or the last two, this is actually pretty easy, because we're just looking to see which box plots correspond to our 5-number summary. So let's just see if we can do that based on the values that we've done for the compact. So our minimum of our compact is 27. So we're going to see, do all the box plots for compact go to 27? This one does not. This lower whisker represents the minimum, and you'll see that that's about 35. So we know that the answer can't be the second one, but it could be all the others. But this one's pretty dramatic in the sense that the upper whisker represents the maximum, and we can see clearly that the maximum is 43 and not 80-something. So that narrows it down to the last two. And actually, it narrows it down to the last one because, once again, our maximum is up there. So we can just go ahead and click this one. And you can see, if you've done the 5-number summary for all three data sets, your compact, your mid-size, and your luxury, they will all follow that. Which, here we go. But we only need to do one in order to do it. Interpret the results in the context of the question in the study and select all statements that apply. Buying a compact car guarantees better fuel economy than luxury cars. Well, they're about the same. All three types of cars have similar spread. That's not true. Compact and mid-size have, albeit kind of different, somewhat similar, but luxury is very skewed. Buying a top 5 mid-size car guarantees better fuel economy than the bottom 5. Mid-size cars have the lowest variability. That's true. Luxury cars have better fuel economy than mid-size cars. No, they kind of overlap. Compact cars have lower variability in fuel economy than mid-size. That's not true. And then buying a compact car does not guarantee better fuel economy than a luxury. That's true. Because you see how these box plots overlap a little bit. So because they overlap, they're kind of comparable. I'll check these and see. Yep, there we go. Consider the following, or consider the study below. Are birth defects affected by a father's lifestyle choice? So we're trying to see, does the father's lifestyle choice affect the acquisition of some birth defect? So we're saying our explanatory variable is a father's lifestyle choice. And we're trying to see, does the lifestyle choice have any effect on the outcome of a birth defect? So that would be the response variable, a birth defect. Alright, so now we're moving on to one of the last sections, scatter plot. So a scatter plot is just a visual representation of two quantitative data sets, meaning, in this case, the scatter plot and table below display the average finishing times and ages of 20 male marathon runners with at least 3 marathons. So the ages are, generally the explanatory variable is on our x-axis. So we're saying age is our explanatory, and the time it took would be our response. And so here are the data sets. They've plotted them for you. So which of the following best describes the relationship between X and Y? Well, if you kind of look, you can probably see that we could estimate, with a line of best fit. Let's see, can I make the pen smaller? Nope. All right. So I can draw in, is that a line? What I guesstimate to be the line of best fit. There we go. And because we can represent this data set as with a line of best fit, look at the slope of the line. Does that slope look positive or does that slope look negative? Well, oops. So if it goes up, that says there's a positive linear relationship. Now, if there aren't any outliers, it'll be pretty clear if there is an outlier in the data set, a value that's not close to the other one. So we're just going to say there's a positive linear relationship. And what a positive linear relationship means is that as one variable increases, the other one increases too. So what the scatter plot is generally telling us is that as the age of the participant or as the runner increases, the time it takes for them to complete the marathon increases as well, which, should make sense to you. And then calculate the correlation coefficient for age and time. So you might have seen in your Lagranita readings that there is a pretty ugly formula for correlation. And luckily for you, and we don't need to do that by hand, because finding the correlation by hand takes a very long time, and we just don't have time for that. So Excel will do it all for you. So based on the pattern of using this function in Excel, if you don't know it, it's fine. Just start spelling out what you're trying to do. We want to calculate the correlation. Well, there you go. C-O-R-R-E-L, Correl. And it tells you, returns the correlation coefficient. And then we just array 1 and array 2. So we're going to highlight our age values, comma, go back, and then highlight our time values. And then it tells us the correlation is 0.849. And it says round to the nearest thousand. Put a 0 before the decimal. Okay? So 3 decimal places is 1,000. So 0.849. So a positive correlation actually provides further evidence of our answer for this first part. A positive correlation means there is a positive linear relationship. A fairly strong one at that as well. The closer your correlation is to 1, that is a stronger positive association. The closer your correlation is to negative 1, that means a stronger negative association or negative relationship. If the correlation is 0, it means there's no relationship whatsoever. It literally would look like you put all the dots in your hand and just threw them at the scatter plot. They didn't make any sort of linear positive pattern or linear negative. So in this case, whereas before the scatter plot moved up, this one moves down, which tells you that as your odometer increases, the odometer reading increase, the MPG decrease. So that would indicate a negative relationship. And there aren't going to be any outliers, so we're going to look for the negative relationship with no outliers. All right. Calculate the correlation coefficient for the scatter plot below. If it didn't give you a table, it's honestly impossible to do this. So you do need a table in order to do this. So highlight your values. Oops, disappeared. Highlight your data set. Copy it, Control-C, paste it, Control-V into Excel. What just happened? We don't want that to look like that. So one more time. Control-C. Control-V. There we go. And then just like before, our correlation, equal sign, Correl, array 1, array 2. So pay attention to what Excel asks for. It just asks for an array. So there's no order to how you're supposed to select it. You can select your Y's first, you can select your X's first, it's fine. But just make sure. What did I do? That's not right. Well, I guess so. So Excel says our correlation is 0. So let's type that in and see if that's right. And it is. So just like what I was talking about before, there is no pattern to this scatter plot. It doesn't look like as one increases, the other increases, or as one decreases, the other one increases. It literally looks like you took those data values and you threw them at your XY plane. No pattern. So it is a correlation of 0. Okay. Well, I'm not going to do the next one, but just know that your correlation here, well, maybe I will, just so we can kind of get all of our cases done. We're doing the same thing. I'm going to just copy and paste this over this one. And because we clicked into our correlation function, just note that that value automatically changed. And we want to the nearest thousandth, so here it is, negative 0.868. So our correlation can be negative, but what this tells us is that since it's relatively close to negative 1, we have a fairly strong negative relationship between X and Y. I'm not going to do this one. Kind of the same thing. All right. chart is now asking us to find the slope of the least squares regression line. So if you look, kind of what I did before, let's annotate this, and let's just say I drew in my line of best fit. So a regression line is just a fancy way of saying line of best fit. If I drew in what I think right now is a line of best fit, there it is, whatever. What this question is asking us to do is essentially find the equation of that line, meaning find the slope and find the intercept. And in Excel, we can do that if we're given all the data set values. But in this case, what's happening is that age is our explanatory variable, time is our response variable, and we're given the number of data values, the mean, and the standard deviation. And underneath, we're given the correlation. So hopefully you've done your Lagrange readings by this point, and we know that there are some formulas in Excel, or there are some formulas to find the slope, the intercept, using the mean, standard deviation, the correlation. So if you do not remember, let's go back to annotate. Let's go back to annotate, and we will do, hold on one sec, let me get back down to this question. Where were we? Here, right? Nope, we were right here. So, if you don't remember these formulas, the slope of the regression line can be calculated by the correlation R times, the standard deviation of Y divided by the standard deviation of X. Sorry, I'm running on my screen, so it's not the best. And what we have, though, is all of those things. We have the correlation, we have the standard deviation of our response variable, and we have the standard deviation of our X values. So what we want to do is just use that in Excel. So equal sign, our correlation is 0.636 times, I'm going to do parentheses, standard deviation of Y would be the standard deviation of our response variable, which is time, of 26.10, divided by the standard deviation of our age, which is 13.24. So the slope of that red line I drew would be 1.25, and we're rounding to the nearest hundredth. Let's go ahead and type that. So we'll type that in. And then the last thing we need to write the equation of a line. Remember, a line is of the form y equals mx plus b. And in statistics, though, we use this form down here to represent the regression line, y hat equals a plus bx. Y hat just means, that hat on top just means a predicted value. We use the line of best fit, or the regression line, to predict values of y. And because they're predictions, we include this little hat up here. So in statistics, instead of mx plus b, we do a plus bx. Where b is the slope, it's the coefficient of your x term, a being the y-intercept. Well, if you remember from Lagrange, I'm going to try and write on the screen one more time, but we'll see if that works. I wish I could make the pen not so. Let's try pencil. Our slope, it's real small. The slope is a equals, y bar minus b times x bar, where y bar is the mean of the y's, x bar is the mean of the x values, and b is the slope that you already calculated. So, in order to find the intercept, you first have to find the slope. And then we can prove these, fairly simple, but we don't need to do that for this class. So the intercept, we want y bar. Well, go back up. Y bar is the mean of our response variable. The mean is 243.05 minus b times x bar. Well, b is 1.25 times x bar, which is 36.30. So there's our b, and there's our intercept. Round to the nearest hundredth, just to reduce the decimal by 1. So it's 197.54. I will be honest with you and tell you that the next question there's some issues with, and I'm going to type this in, and I'm going to say probably, even though we got the answers for the first two correct, this is going to be probably considered wrong. And it all depends on rounding. See, it wanted us to, I think, use the rounded value of 1.25 to find the intercept, but I will be honest with you and tell you that something that tricky will not be on your test. You don't have to worry about getting it wrong because you clicked the value. Let's see if that's what happened. No, still. It has to do with the rounding, with the slope, and with the intercept, and in all honesty, don't worry about it. It would be more like the ones with your homework, I think, where you find these values and then you use the line of best fit of the form y hat equals a plus bx to predict a value of y. So this is considered correct. Please don't worry and don't stress out about it counting it wrong. I know it's there. It has caused a lot of, some stress for us and for you guys. See, it rounds it a little differently, so don't worry. We're close. We know that we're right. Alright, so which of the following is the correct interpretation of the slope of the least squares regression line? So, if you remember, back in your algebra classes, maybe high school or maybe you took college algebra here, the slope is just calculated by the difference of y over the difference in x. y2 minus y1 over x2 minus x1. So we can consider the slope being, if I increase x by some amount, how does y increase as well? And because it's a line, it's going to be constant for every similar change. So the way that we describe the slope of the regression line is something similar. As x changes, how does y change? Where did it go? Here we go. So let's go back down to their interpretation. So our slope is 1.25. Don't get it confused with the intercept. So 1.25. So as x increases, how does y increase? So we would say when x increases by 1, y increases by approximately or about 1.25. So x in this case represents age. So for every year a runner's age increases, 1 year being 1, his total miles run is likely to increase by 0.9 miles. Nope. We're looking for 1.25. So I see 0.9 there, not it. So for every year a runner's age increases, his finishing time is likely to increase by 1.25 minutes. Because x was our runner's age, finishing time was our y. So for every 1 unit increase in x, on average, our y will increase by the slope, or decrease depending upon if it's positive or negative. In this case, positive. And I'll interpret another one for another question. I don't know if it's going to ask, but I'll do it anyways. So use the slope and intercept use the slope and intercept calculated above to write the equations of the least squares regression line of the form y hat equals a plus bx, and use it to predict the finishing time for a 26-year-old male runner. So what we're doing is, because our age is our explanatory variable, it's our x value, we can just say, we can plug in 26 into our regression line. So we can do 197.54 plus our slope times our predicted value. So it looks like a plus bx. And Excel gives us nearest hundredth, well we got to the nearest 10,000, so we reduce by 2. So Excel predicts, not Excel, but our regression line predicts that if you have somebody who's 26 years old, it'll take them about 230 minutes to finish the race, to finish the marathon. Now, it's not going to be exactly 230 minutes, but we're talking about predictions. We're using our data set to make our best prediction about how long it would take for a 26-year-old. Okay. So this question relied on the fact that it gave us our correlation, it gave us the standard deviation of y, and it gave us the standard deviation of x. So we would have to use those formulas in that situation. But if you look at the next question, 38, we're not given any of that. Instead what we're given is our raw data. So I'm going to copy this and put it in Excel. And you'll notice that it's also in an ugly format. It's on 2 rows, or actually 4 rows. We want it to be all in one. So I'm going to highlight this, just click cut, and then paste it next to the other data set. So now it's on, each value is on 1 row. I'll delete these. So we can use Excel now without those ugly formulas to figure out the slope and the intercept. Well, as I said before, and as I've been kind of talking about, whenever you're trying to find, the function in Excel is probably that name. So slope. That's what we're trying to find. Returns the slope of the linear regression line. Click it. Pay attention, though, to the syntax, because if you don't follow that syntax, you will get the problem wrong. Known y's, known x's. In this case, look at our scatter plot. Our y's are MPG values. That's our response. So we highlight these, comma, go back, and now Excel changed, and now known x's are bolded. Come on. And there's our slope. So we want this rounded to 2 decimal places. Negative 0.01. Now if we look at our scatter plot, there's a slight negative trend. As our odometer readings go up, our MPG goes down. So our slope should be negative. So please use that as like a mental check. Negative 0.01. Answer is correct. Intercept. Well, we're trying to find the intercept. And then there's a function in Excel called intercept. Known y's, known x's. Alright, so known y's, comma, known x's. Same format as before. Y's first, x's second. Rounded to the nearest hundredth. So click it. 2 decimals, 30.85. Here we go. And you'll see it's kind of correct. So this is actually a faster way. If you're given the raw data, using Excel to find the slope and the intercept is actually much quicker than doing other formulas. But it's all about what data you're given. Because you'll notice, even though we were given the raw data with this it's a question like that. Never mind, ignore what I'm saying. Alright, so now, what are some possible lurking variables? Select all that apply. Well, a lurking variable is a variable that affects your response variable that you really didn't think about. So in this case, we're looking at how the odometer in your car influences your miles per gallon. So, what are some things that affect that? Well, it says assume that all cars are maintained in accordance with their manual. Alright. So, the maintenance schedule of vehicles, terrain which the vehicles are traveling, that could be a lurking variable, Cars that are driving on rougher terrain tend to have different miles per gallon. Additional weight, that's something to consider. Experience of the driver, make and model, the speeds. I'm going to check all of these, because it says that they're all in accordance with their normal schedule, so this is incorrect. Let's see if I have to check off 5. I don't think so. Terrain, additional weight, the make and model, the speed. No. Why? Let me read this again. Stat top below, I'm going to see what's telling me a few cars with the same advertised fuel economy over the mileage driven. I'm going to guess now, actually, that all of them could be lurking variables. That's probably the best part, the best answer. Come on. Answer, train with the vehicles are traveling, additional weight, and the speed. Well, alright, I'll get that. So, in this one, just know that I think they all could argue. The maintenance schedule, I guess that one wouldn't be because they're all being maintenance in accordance to their manual. The experience of the driver, alright, so they're neglecting that. That makes sense, actually. The experience of the driver really wouldn't have a major effect on how the car is being driven. So, and then the make and model. Alright. So seasons. The speed affects your miles per gallon and things like that. All right. So use this little intercept found to predict the fuel economy at 225. Well, we have the values, equal sign, intercept plus the slope times 225. So the nearest 10. Come on. One more. 28.5. Alright. Almost there. So these next questions deal mostly with sampling and how do we conduct and how do we get a proper sample from a population. So you work in a 12-story office building with approximately 1,200 employees and approximately 100 on each floor. Suppose you want to determine the breakfast of choice for employees in your entire office. Which sampling method will produce the least amount of bias? So when we talk about bias in the sense of experimental design, we talk about some outcomes being more favored than others. You know, if you're in a high school, I don't know, and you want to know the average number of students who drive to school, and you go and stand in front of a bus lane and sample kids as they get off a bus, that result you get is going to be biased because it does not really reflect the actual value. It's systematically favoring students who don't actually in fact drive. So here we want to sample our office. So if you post a survey on a bulletin board on your floor, asking all employees to participate, not the best way of doing it. Who reads the bulletin board? You can't say. Obtain a list of employees on each floor and select 30 people at random from each floor. That's probably the best. Obtain a list of employees in the entire office and survey every 20th person on the list. Stand at the front entrance and survey the first 100 people who enter. So this is a simple random sample. Obtain a list of employees on each floor and select 30 people at random from each floor. Actually, this is more of a stratified sample by floor. But this will give you the most accurate representation of people in your office. You are a district manager. Oh, wait, did I go too far? Yeah. You're a district manager of a restaurant chain and want to study the job satisfaction among employees in your district. There are 10 restaurant locations in your district with approximately 40 employees at each location. Well, the first one here. Obtain a list of employees by location and survey 20 employees at each location. That gives you the best representation of your employees. Now, post an online survey, that generally is never going to be the answer because only people who respond are going to be people who actually go to that particular website. Alright, let's move on with these. Best method, Alright, so which scenario represents a stratified sample? Choose all that apply. So the biggest thing with stratification is that your population of interest is separated into groups. I don't even think I need Excel for this anymore. Your population is separated into groups. And what might confuse you is that there's also another sampling method that also separates participants into groups, and that's cluster. So one of the things that you have to know is what is the difference between a stratified sample and a cluster sample. So a stratified sample means you're going to break your population up into groups, and you're going to randomly sample from each group. So if you broke your population up into 5 different groups, you're going to sample 20 people from each of the 5 groups. Cluster sampling, you break your population into clusters, but instead of sampling from every cluster, you decide to sample everybody in maybe 2 of the clusters. So, and that's the biggest difference. It's really, do I sample from all of the groups, or do I sample everybody in 1 or 2 groups? So here, a stratified sample. A sales associate from a cable company surveys the first 50 people who enter a retail store. Nope, that seems to be more convenient. The district manager of a grocery store chain wants to study the job satisfaction rates of employees who work in his district. He obtains a list of all employees by store and randomly surveys 50% of the employees from each store. So they're basically saying each store represents a group, and we're surveying half the people from each group. A school district superintendent oversees 5 schools in her district. She surveys all the teachers from 3 of the schools. That would be a cluster. A governor introduces their constituents' views on gun control with our state. She obtains a list of registered voters in each county and randomly selects 5% of each county's population to be surveyed from each county. Yeah. You're interested in studying secret? Nope. Yeah, I would say that's probably the best one. There you go. The salaries of 50 people are collected as a research project. These salaries are separated into 5 groups, and 2 of the groups are chosen at random. That is a cluster, assuming that everybody in that group is sampled. You were asked to conduct a survey of 10 people regarding their favorite cell phone manufacturer, and you asked your friends, what type of sampling method is this? Let's say convenient. Yeah. If you ask your friends, if you ask people that are easily obtainable, that's more convenient. You're an HR rep for a large investment firm. You're conducting a study on what airline your fellow employees prefer to travel on when conducting business within the U.S. You choose 5 of your firm's 10 largest locations at random and survey each employee at these 5 locations. I would say it's more of a cluster. If they are, maybe convenient. Yeah, no, it's a cluster. You're getting 5 groups and sampling everybody in the group. Alright, let's keep going. This is more of just definitions. Yeah, let's see, what is that one? I'm trying to get every one of them. Your uncle is a park ranger doing a study on whether millennials know the locations of various national parks. He contacts you, suppose you are a millennial, and asks you to take the survey and share it on social media with your friends. What type of sampling method is this? It's probably convenient, just because it's, he's asking you, somebody who is a millennial, and it's convenient for him. He doesn't really have to do much. Your company is preparing to purchase new company vehicles and wants input from employees. There are approximately 350 employees in your company across 15 different locations. The boss wants every 5th employee on an alphabetical list. That's systematic. In Lagany, that might have talked about every 8th person or every 5th or 6th person. That's a systematic sample. If you start at some value, you go every 5 or every 6, every 10. You're systematically choosing people. Alright. Alright. Let's keep going. Alright. That's basically it. I guess we can interpret the slope one more time to make sure we're good with that, but other than that, we've basically got every single question on the review. And if you're ever still stuck before you take the test, you can feel free to email me or Dr. Meadows. We'll be more than happy to help you. I've already done this one. Okay. That's where we can. Oh, I was done up. Never mind. So here we have another data set where, let's see, did I have a lot of sheets here. Alright, so we have a data set, but it's summarized for us in terms of the number, the mean, and standard deviation. So I'm just going to go through this pretty quickly. The slope is the correlation 0.671 times the standard deviation of y divided by the standard deviation of x. Wow, 46386.14. There's our slope. 2 significant digits. So extend it out. There's our 2 significant digits. Let's see, negative 0.000097. Alright, the intercept is just the mean of y, 29.74, minus the slope times, minus the slope, minus the slope. What did I do? Oh, I didn't do an equal sign, that's why. 29.74 minus the slope times the mean of the x, 96416.67. So there's our intercept, 30.67. And we can write the equation of the form y equals a plus dx. Some possible working variables. Let's do this one again. The terrain in which the vehicles are traveling, the additional weight, and then the speeds. There we go. Got this time. And then use the least squares regression line to predict the fuel economy. So the interpretation of the slope, though, for every unit increase in x, the predicted y will change by about this much. We have to think about our unit for odometers is actually in thousands. So we can take our slope value and times it by 1,000. And say that for every 1,000 miles driven, the miles per gallon will decrease by about 0.00969. And then we can use this line of best fit to predict something at 200,000 miles. And you can just plug it in for x. Alright, so that's basically it. And we can do, by the way, intercept plus the slope times, well, let's see here. Why did I type in 200,000 versus, or why did I type in 200 instead of 200,000? That actually is an important question. So if I type in, and most of the time you can kind of, if I typed in 000, which one is it? That's the matter. So pay attention to your units, because our intercept, we want x at 200,000 miles. So let's pay attention to your value, 28.74. And I knew it was wrong by typing in 200, because our intercept is 30.67. If I left that as 200, I get 30.67. And based on our slope, our values need to decrease as the odometer readings increase. So if I typed in 200 and it's wrong, and it's the same as my intercept, something's wrong, and I probably should go 3 more. And that is a decrease in our miles per gallon because our slope is negative. Well, I hope this helps, and as I said, if you are if you're confused about something and you have more questions, please ask the assistants in the line office for help, or just email me or Dr. Meadows. Have a good one.